Yes.
Okay. Is it everything good? Okay. All right. So as we were saying, we want to make sure it gets in 125, and the CAP deadline is fastly approaching, and we want to make sure we can get a lot of the SIG auth and probably SIG machinery to look and review, right? So just want to give them enough time. And so, yeah, so this is the draft document for the CAP issue and PR. I don't know if y'all had a chance to review it. I only got I got comments from Anish, so thank you for doing that. Do you want me to go through this real quick to provide some context, or jump into the items that we need to discuss and agree on? What would you folks prefer?
So I have been out of office, so I have not read anything, and also people don't like to respect my half day and make me do things that are not fun on my half days. So the time I planned on spending on this was not used on it. I'm sorry.
No, I mean, I just sent it out yesterday, so.
I was definitely out of office yesterday.
Yeah, I didn't expect everyone to have gone through it. That's why maybe I can just quickly go through it.
Do you mind pasting the link in chat real fast?
Oh yeah, sure.
But yeah, I'd love to
Chat.
go.
This chat, you mean?
Yeah, I mean, because I'm going to put it in the SIG auth agenda too. That way, people, if anyone cares to look at it.
It's also in the. It's also, I put it on Slack as well.
Okay. Thank you.
But yeah, whatever is easier. So yeah, so a couple of things we need to confirm. Are we okay with the title? I should highlight this. So anything with yellow, it means we need to discuss and agree on. So one thing I just want to confirm is, I think we said, even though the observability CAP got merged and it got approved, but because it's very closely related with everything else that's discussed in this CAP, we are actually merging it back to this CAP, and then so that we can discuss it together. And also, I think there were some minor changes since the CAP got merged. So yeah, so the point of this CAP is introduce V2 Alpha 1 API to app performance rotation observability improvements, right? And we want it to be alpha in 125, beta 126, and GA in 127, right? Moving on, this is all just whatever. So yeah, so the summary is for this CAP, which we are proposing for the key management service contract, and the key hierarchy design in KMS plugin. And these are the things that we're enhancing, right? Improve readiness time for clusters with large number of secrets, reduce the likelihood of hitting the KMS rate limit, enable fully automated key rotation for the latest key, improve KMS plugin health check reliability, improve observability of envelope operations between the API server, plugin, and KMS, right? This one was a little bit like, I don't know how to say it in a clear way, but I wanted to highlight that it's not fully automated key rotation for every type of key, but rather for like the latest key, right? I don't know how to say that like more clearly, but that's something that like may be confusing for people if they're not familiar with this. Again,
I guess,
stop me.
No, this is just the summary.
Yeah, sure.
Which is fine. It's I think there's a lot of things we've talked about, and trying to even summarize them into
I know, yeah,
these bullets is going to be hard.
Yeah.
I think one thing we want to make sure is clear throughout the KEP is like things like the like reduce the likelihood of hitting the KMS rate limit.
Mhm.
That is purely an implementation detail of the reference implementation that we're providing, right? It's not actually enforced through the V2 API in any way
Mhm.
that the plugin use a hierarchy, right? We're just saying that this is a large enough problem and it occurs commonly enough that we believe that we want this to be a first class supported thing in the implementation that we provide as the baseline. But we are not going to mandate in any way that you do use said implementation.
So maybe to provide a baseline for. I mean, I get your point. Yeah.
You might, there might actually need to be two buckets. Like,
Okay.
what does the V2 API try to accomplish? And then a second list of like, within the reference implementation that implements the V2 API, here's the extra things that we try to accomplish because we believe that basically everybody needs these things, or at least the majority of users need these things. So this is how the V2 API enables that. And then also like, we realized that many KMS implementations are based on underlying REST APIs that do enforce strict limits on encryption operations and just general IOPS. We didn't think that that is a concern of the actual V2 API. Like we didn't think that that was a core requirement that that API somehow handle. Like somehow within the API server, we reduce the number of operations we do. We believe that the plugin layer is better for that. But instead of telling everyone, go solve this problem, we also want to solve that for them in a good, fully featured implementation. But also this fully featured implementation won't force you to use the hierarchy. It'll just be the default mode of it to try to use the hierarchy. And then there'll be some switch to turn the hierarchy off because maybe you don't want it.
Mhm. How does this look? I do think this is sort of the diff, right? Meaning I think the key hierarchy design is the reference implementation, which improves the readiness and reduce the rate limit, whereas everything else is what we're introducing, right?
Yeah, so we're doing the so the V2 API enables that rotation, and it definitely enables the health check because it actually adds an API for health check.
Yeah.
And it includes the observability stuff. As an aside, I think what we might want to do is actually like the observability KEP, we might just need to like retract it. So that way people don't get confused and think that we're trying to do that KEP in two places. Like I could imagine a world where people say that we should try to somehow shove this into the V1 API, but I really rather not try to somehow come up with magical migration strategies from that old thing to this thing. I rather just support both for enough releases and just tell people, please just use the new API and figure it however you want to migrate.
That's a good call out. I think this is more clear. Yeah.
Yep.
And I initially started writing this in here and it was just way too much. And I actually think it belongs in motivation. So if people want to know why we're doing this, like each bolded thing has its own like section. Okay. But I think as a summary, if I'm just coming in quickly, like, years from now, looking at this change, all I need to know is what is this service, what is this new API adding, right? And how does that impact plugin implementation?
So quick check, Anish, Damien, do y'all agree on that summary? Is there anything we have left out that was an important aspect of all of the work that we've been talking about?
No, I think only for the rotation stuff, so Rita did mention it's with the local KEK, right? And the one question that I wanted to bring up was, do we also want to mention about the storage hash and the whole thing that we have been thinking about? Like, does that fall under the scope, or do we just say it's not under the scope, but it's something that we will look into?
So the storage hash is that rotation bit, right? That rotation is referring to rotation enabled by the storage hash and the key ID that's emitted in the V2 API. The rotation within the hierarchy is, I guess, an implementation detail, maybe. So there's probably some very specific words we have to use to help people understand?
I think, correct me if I'm wrong, I think you're talking about this, right? Anish. This is this, like
No, if you
the,
scroll up, like I think the part where you have in motivation the rotation. So we have the current key ID and the observed key ID, right? And I think Mo had this idea that when the KMS plugin starts up, when it does the status check, it says, hey, I'm using key ID 1 from Key Vault. This is what I'm configured with right now. And then let's say after 1 hour or like 2 hours, now it has key ID 2. It's configured with key ID 2. Like it's possible that there's another instance or like someone changed it in the backend or it just did that during runtime, right? So in this case, now the KMS kek has been rotated. So we need to handle that rotation. And then the idea was there is a storage hash, which will have the status response, hash it, and then store the hash. And then when the key ID changes, now the hash will change because the status response says like, hey, I have a different key ID. And that could be a trigger for auto rotation. So basically like some component looking at it or a user looking at it can say, oh, this key ID is changed. So maybe I just have to do kubectl get secrets, replace all, so that I can decrypt and re-encrypt, or if it's some other control plane component looking at it, then it can automatically do it.
Yeah, but to be clear, this is unrelated to the key hierarchy in any way. Like it has nothing to do with that hierarchy. It's purely the real root key within your KMS, whatever implementation you have, right? So yeah, I did plan on that bit being in this KEP because I thought it was important for the rotation, right? That's why the key IDs in the V2 API is to enable that. But the implementation of that does need it to be observable outside the API server. And maybe folks agree that that's storage version hash. I'm not tied to that. It was just the closest thing I saw that existed already that gave us a good approximation, right? We don't need, like, we don't have a status for the API server to shove that data in. But to me, storage version hash actually roughly has that meaning of like, how do I store bytes on disk? Well, encryption is part of how you store bytes on disk. That's why I thought it was okay.
Right. And I think Rita already has most of that written under motivation and rotation. Like we probably just need to add details on the storage version hash and all that. Maybe in implementation details or something, like just show examples in them. Because the local kek being rotated is a reference library implementation. So like that is not something that we have to put in detail, but probably just the storage version hash.
So this is mentioned in here. But it's like way down in the implementation, in the design and implementation. I purposely didn't want to introduce it too early because it's, unless you understand like enough about this current key ID, you're going to be very confused reading this. That's why it's way down. So
yeah, I mean, I'm not hopeful that most people will have any idea what this KEP is.
Well, by the way, that's how I was like, wow. Like at first I was like, we should probably have separate KEPs for this because it's very long. And also, but then as I'm writing it, and Mo, I agree with you. It's like, because they're actually very much related. And
yeah, everything flows from like one idea. Like this is the core change we want to make.
Yeah.
The big change, by the way, here's like 50 reasons we want to make this change.
Right, but except this one change is actually impacting various use cases and various pain points, and because of that, it takes a long time to explain and not confuse people. So coming back here, like we don't need to go through this because you already know like the pain points.
Just maybe to go back to the summary, I think what's missing is actually like mention of the reference library that we want to add, because at the end of the day, like one of the main problems that we were trying to solve was to reduce the load on the KMS, and that's what we will be solving with.
Does this help?
Library. Yeah. I don't know how I missed it, but yeah, definitely.
No, we were just talking about this. So this
we were like tweaking it probably as you were reading.
As we're talking, yeah. Let me know if I can make this more clear. Like
No,
this,
it's very clear now. I just
Okay,
read
awesome.
the previous one.
Nothing like live document writing. Shall we move on? You guys okay?
Yeah, I was gonna say, I did see below, I think, something that I disagreed with, which was, I think the proposal for how to store stuff.
Okay, I'm happy to jump forward to
But yeah, it was lower, but we can,
I still think there's benefit of just going through it once together so that at least you know. Yeah, okay. That way you can give me feedback to how to make this better, right? So, all right. So goals, just basically copy paste of what's in the summary. And then non-goal, I specifically said, we're not here to prevent KMS rate limiting. We're not here to recover any CACs if it's deleted using the transaction ID for auditing. This is copy from
if you delete your key, sorry.
Whatever, yeah. Anyway, if there's anything, more than this, please add. Just this is what I was thinking about. That's all. All right. So proposal. So I started with key hierarchy because I think it's an important detail to introduce first so that people understand why we're adding current key ID. And then once they understand how this is being used, then we can talk about how it's used for rotation, right? So first, the proposal is support key hierarchy in KMS plugin that generates local KEC, and then add v2 alpha 1 in Kubernetes to include current key ID and metadata to support key rotation. Current key ID is the KMS key ID stable identifier change to trigger key rotation and storage migration, right? Metadata, it's a structured data, can be the encrypted local KEC and can be used for debugging recovery, blah, blah, blah. Now let's talk about the first highlighted item, validation, similar to how Kubernetes labels are validated today. This was something mentioned in one of the prior calls. And Anish also brought up, how do we validate this, right? And I actually, as I was writing this, I actually thought it didn't make sense that it's a free form. And the reason for that is there is somewhat of a contract, right, between what is returned by the encrypt response and then how it gets passed back to the KMS plugin as part of the decrypt request, right? So how does the plugin find the encrypted local KEC, right? So the key that is used in this metadata.
Right, but this is why it's opaque, right? That hierarchy is purely an implementation detail of the plugin. So the contract is between the plugin and itself, right? The API server just says, you give me some unencrypted data that you have somehow figured out not how to put secrets in, or you have encrypted them.
But if not implemented correctly, then it's always going to be a cache miss if not implemented correctly, right?
You cannot guarantee that your plugin is ever implemented correctly.
Sure.
Right. Think about the alternative, right? Say there is a contract with specific fields. What if I'm a newer plugin implementation that needs like a annotation basically that tells me my root key so I can figure that out, right? But my concept of root key is completely different than whatever we came up with. Now I'm stuck, right? Because I don't have a field to put it in. So what I'm going to do is take an existing field, put like a pipe character and like put the first data there and the second character there, like, and just like hack it in, right? Because like even if we give you just raw bytes, you could put anything you wanted in there. All we're saying is, let's not do that. Let's give you a map that's like labels. So that way, if a human being ever tries to read this proto on disk, they can see high level structure and kind of make sense of it, instead of being like, there's a completely opaque binary string with arbitrary encoding that I don't understand, so I can't look at it at all, right? Like it's to just encourage, like, if you need many fields, don't try to shove them into one. Like if you look at the thing that what was that name of that Google thing that we originally looked at that had key hierarchy support? But the what it did was it encoded everything into a flat proto array at the end, and that's what it passed around because it's like, I know you can store bytes. Here's some bytes, right? And I was like, that's exactly what I don't want is flat bytes because they don't have any structure to them when you observe them, right? So
Okay.
by forcing you to do this semi-structured thing, at least we can kind of read it, right? So we increase the chance that plugin authors are encouraged to just use separate fields for separate things. That's all I want out of this because it has to stay opaque to us. And we do need a scary message saying this is unencrypted. Do not put secrets in here unless you pre-encrypt them somehow. Then it's fine, but like don't put secrets in here.
And is the idea that it will be a global variable that the plugin defines that will be shared across the decrypt and encrypt request and response? Like, I just want to make sure we have a more a less error prone way to make sure the plugins do the right thing.
Yeah, so like if we think if we think about what the reference implementation might look like, I would imagine at least two fields being included in the response. One would be the whatever its true root key is in the external KMS, right? And that's to help with lookups. So that way, when it sees the decrypt response coming in, it knows what key was the true root key for everything. And then the second thing would be like encrypted key, and that would contain the encrypted blob that was the local KEK at the time, right? So it'll look up in its cache and say, can I decrypt this local KEK thing? Yes or no? If it can, it'll just do that and just have it. If it can, it'll be like, okay, what did I actually use to encrypt this thing with? And that way I can look it up if I need to. And it could also then fall back being like, well, if that key for some reason isn't there, granted it should always be there, it could decide to be like, all right, I'll just try the latest key or something. I'll try all my keys, whatever. But that's all it needs, right? It just needs those two fields to basically be able to, and just correct me if I'm forgetting some field that you actually know better than me on this.
I typed the exact same thing on Slack for Christoph. So
okay.
Whatever you said, I just summarized that for Christoph as well for the reference implementation. But what you said, right? Basically, like when the decrypt request comes in, if it's a cache miss, it basically has the key ID and then it also has the encrypted local KEK. So it can just go make a one call to KMS, external KMS to decrypt it, and then it can store it in the cache. Like in the POC, the first time that we did without the key ID field, we were actually just trying all the other key IDs that worked. But now it's more deterministic. Like when it actually sends as part of encrypt response, it sends the encrypted local KEK, and then it also says which key ID was used to encrypt it. And then during the decrypt request, the expectation is you get both of it. And then you look at
the expectation.
Right, but the current key ID, observed key ID is actually like, it's part of the proto request. So it's not part of the metadata, right? Like we can still say.
I'm not worried about current key ID. I'm
right.
worried about metadata because it's,
right.
What if you didn't give us the same key, like key value pair, right? What's going to happen?
Yeah, I mean, I would expect the plugin to just fail, right? Because it's basically a bug in the plugin. It handed metadata, like we're going to assume the API server is correct in that it hands you back exactly what you handed it.
Right.
It's easy. That's actually super easy for us to get right. But on the other side, like if you never gave us the right data to begin with, we can't respond with correct data. We're blind to told us, right? But I think I'd be very surprised if someone got this part of the implementation wrong because it just wouldn't work. It would consistently not
because
work.
It's the same variable.
Yes. Like it like the input.
That's fair. Like, I don't know. I was just thinking about corner cases. Again, back to this, right? So what kind of validation are we talking about here?
I think we could just use the same validation exactly as labels does today. So that means keys would be very restricted. Well, keys would have to basically be host names. Is roughly the requirement of keys, and then values I think can be basically anything, but then there's an overall size limit of like 1 megabyte or something, or like half a megabyte, which also seems totally reasonable and fine. Like don't spend more than that because it's like what. So I think that's probably good enough. And labels are pretty restricted. And I kind of like that. Like, I don't feel the need to be like, you can store, I don't know, random foreign character sets that I don't understand, that are not UTF-8, because I just don't feel the need to support that. Yeah. And I honestly can't imagine it being too restricted, right? Like,
yeah, I think the size limitation is what I was worried about. And like I mentioned about that in one of the calls, like if I'm a KMS plugin, I can just add anything and like make it really big and just keep sending stuff.
Yeah.
And expect API server to store all of it.
Yeah.
Yeah. But as long as we can impose the size, and then like I didn't know where the restrictions for the label, so that's why my question there. But I think now I understand that the host name and those kind of requirements, so that's fine.
Yeah, as far as I know, labels is like the most strict map we have. Like, I think it's more stricter than like the config map and secret data, that the data field has relatively strict restrictions, but I think labels is more restrictive on size and stuff. And it's more restrictive than annotations on the key names. So I think it gives us basically the strictest, but like nobody really complains about labels, right? Like it's fine, it's robust, and works. So I can't imagine anyone complaining about this either.
Okay, I just added this here per, I think this is a good point. So
yeah, and we can like we can validate offline and make sure that I have not misremembered the restrictions on labels, just to be sure.
I think there is a restriction for sure.
Yeah, because we don't
Yeah.
want people using labels as a database,
Right.
because they would.
Are we good with this one? Should we move on? Sorry, I'm rushing a bit because it's pretty long.
Yeah, no,
we
it's
don't
good.
have, we have 30 minutes. Sorry, I'm not like trying to, you know what I mean.
Yep.
All right, we're good. Status request, response return. This is the status new API, return version, health, and current ID. The current ID and status can be used to compare and validate the key ID stored in cache and latest encrypt response current ID to ensure they all line up with the status response and update if it's stale during storage migration. Generate, oh yeah, this is observability now. So are we good with this one? This is a lot.
I'm like reading it again. I was like, what does this say?
Yeah, so it's basically, this is basically explaining how this in return by status response is used as the key ID to validate between that cache and the latest encryption that we just happen to use whatever key was used to make sure they're actually all matching.
Okay, now I get it. So this isn't exactly what I had imagined.
Okay.
I had imagined that we would, within the health implementation of this, the health checker implementation, that wires up to the health endpoint, which would be like part of this whole one global internal object that contains the KMS status.
Sorry, just to make sure we're talking on the same thing, this, right?
Yes.
So that is the status response. Yeah. Okay.
Yes. And so this is being called inside the health checker implementation of the API server for this KMS endpoint, right? And so within that, we're going to basically know the current level we are and use that to push into the storage version hash. I was not going to, so the idea is that keeps us at a particular level, but as we're interacting with encrypt and decrypt, right, we'll just store the ID that we see within those responses, but we won't try to correlate it in any way other than when we do a decryption. And we would basically say, okay, I did a decryption and it said I'm using key ID 3. And at that instant, I see that my level from the status is 5. So I know that's stale. But as a, for example, the level does not change because of any response in encryption and decryption, because those can happen in arbitrary orders in parallel, and we don't want to accidentally go back in time, right? So basically, your level only follows status, and then encrypt and decrypt sort of record point in time results and compare to that level, and that's sort of it. Does that make sense? It's kind of like, it's really hard to explain without just writing out the code, because it's very imperative. Like, it's not a declaration of any intent.
Yeah. How do I write this?
I think it's okay not necessarily to like nail down exactly this, because this is really specific. I think as long as we say that we are level driven by status, and so that just drives our level up, and during storage migration, or basically during storage operations, we compare that level to what we see either in our cache or when we call the API. And if there's any mismatch between either one of those, we say that we're off, like we were stale. That's it. I think that's all you really need to be able to say there.
So I think in this sentence, I should probably add it can be used to compare and validate on decryption requests based on what you said.
Yeah, so on decryption, we have two paths, right? We might either use a cached deck, or we might go to the external KMS, right? And in both of those situations, we learn which key ID is used in that transaction. And from that, you can decide, did that match the level that status is currently at, yes or no? And if it doesn't match, you say you're stale. But that's basically it, right? And this is distinctly different from the staleness check that exists today. Today, staleness is only possible if you have to go down the list of encryption configuration options in your static config. That's the only way to get staleness, is if you basically use something that's not index 0. Now we're saying that no, you can actually get it at index 0 because of the specific nuance of how index 0 or any index can be configured if it's one of these new V2 thingies.
I changed this to the last, not the latest.
The current,
because it's the last key ID that was returned to us from the last encryption response, right?
Well, remember though, like you could have multiple requests at the same time, causing multiple encryption things, and they don't have a defined order then, right?
Right.
They could return it. That's why I'm saying that these are separate. They have to be kept separate. One informs about staleness, and one informs about level. That's why one of the particular requirements of this implementation is that there can only in memory be one piece of code that talks to the KMS plugin, because it can only have one understanding of its level. Because today the health check implementation and the storage implementation are separate, like they're two pieces of memory that don't know anything about each other, so they can diverge in their understanding of levels. That's why I'm like, this is a very important implementation detail. It's very hard to get right, because we have to basically say no, code base, you can only make KMS stuff once, and once you make it, you reuse that object instead of recreating stuff, which is the correct way to do it, but that's not how the code does it today, because it doesn't actually matter today.
Well, and we're assuming that the key ID in status response is, it is true. It like has more weight than these, right?
Yeah, because we're saying that will happen at some deterministic period, right? Like every 10 seconds or whatever, right? There's only one of those requests at a time, and they promote the level up no matter what the value is. They just say that this is the current level. Whereas encryption and decryption responses happen arbitrarily. Some, a request that started at time 0 might take 5 seconds to complete because it just happens to be a bad request or something. Whereas one that started at time 1 could complete before it. And that's what I'm saying, right? We don't want to accidentally go backwards or forwards in time in weird ways that we don't want. We just have one meaning of going forward, and then everything else has to just believe that that's truth.
Okay, then I guess the latest makes sense.
Yeah, it's like this is very hard to explain and just.
No, I mean that's why I want to make sure I use the right words, even though to the untrained eye, it's like, what's the difference? I don't know. Anyway, hey, Christoph.
Hey ho!
Happy birthday!
Happy birthday.
Thank you.
Glad
Ella.
you can join us. we're just talking about current key ID and how it can be used to trigger a storage migration, I guess, a rotation. Are we good with this section then? Again, this is still not implementation detail yet. This is still
Yeah,
just
we gotta keep going. We only got 20
high
minutes.
level proposal. Yeah. Okay. All right. Y'all know what this is. Nothing new here. Enable fully automated rotation for latest key in KMS. And I put in prerequisite encryption configuration is set up to always use the latest key version in KMS. And the values can be interpreted dynamically at runtime by the plugin to hot reload the current write key. Rotation process sequence. Record initial key ID across all API servers. Cause key rotation in KMS. Observe the change across the stack. And then the storage migration.
Yeah, I think that's a good high level thing. I think the only bit that within a high level description is like 1 and 3 are infrastructure dependent. So we cannot give you steps that will work on all infrastructure that because it depends on how load balancers and IPs and basically API server identity or networking identity works in your infrastructure.
Or should I say the infra provider?
Yeah. Yeah. So, in OpenShift, there is a guaranteed way to find the address of every API server. That's not true in all the cloud providers.
Yeah. What about the storage migration? Like that
Storage migration, we can cheat and just run the storage version migrator. So if you do steps 1 and 3 correctly, storage version migrator guarantees that it'll do the right thing in that instance.
I mean, I feel like we should at least mention it. I can't spell.
Yeah, that's totally fine. Basically, the storage version migrator says that if you guarantee 1 and 3 have been done correctly, it can do storage migration for you. Because it uses storage version hash and stuff to basically figure out what it needs to do. I
should say this is a user action in the KMS, right? I mean, just to be clear.
Yeah, I would maybe say in the external KMS as a way of trying to distinguish between the KMS.
Makes sense.
Do we want to find a common name for it, for, I don't know, remote KMS, local KMS, or upstream KMS, downstream KMS?
Yes, we should. I don't have a strong opinion on the string that we choose, but we should.
Remote. I think external does hit the point though, because it's.
I don't care about what word we pick, but I agree with Christoph. There should be a word that we consistently define, and there might actually be there should probably be a terminology section at the top where we say like external KMS means blah, blah, blah. For example, cloud KMS in this provider or this other, like just to be very specific with examples. So that way.
And the contrast and the opposite of external would be internal KMS.
What is the internal
KMS?
Like a Hashi vault thing?
Well, I don't know what internal KMS would mean.
The plugin that we're running.
Yeah.
That's not a KMS though.
Okay, good.
Right? When we say KMS, usually it means it's outside of Kubernetes.
Okay.
Yeah. You know what? Let me be very. How about that? Just to be extra clear.
Yeah, totally right.
Actually, that's confusing too, because it could actually run in the cluster.
Yeah.
I know.
And I don't know. Let's keep going.
Yeah, I'm going to highlight this and I'll add a definition for it. How's that? I think that would clarify some things. Moving on, details. Support key hierarchy and generates local CAC and add V2 service contract in Kubernetes to include current ID, metadata, and status. Key hierarchy in reference implementation. Maybe that will help. So what we said was no change in API server, keep one-to-one DAC mapping. KMS plugin generates its own CAC in memory. Real KMS is used to encrypt the local CAC. Local CAC is used for encryption of CACs sent by API server. Local CAC is used for encryption based on policy. Since key hierarchy is implemented at KMS level, say KMS plugin level, by the way, the terminology I've been using is KMS plugin. I know we go between plugin provider, but I changed to plugin because provider could mean something else. Anyway, it should be seamless for API server. So whether the plugin is using a local CAC or not, the API server shouldn't care. Same behavior. What is required for the API server is to be able to tell the plugin which CAC, what local CAC or KMS CAC it should use to decrypt the incoming DEC. To do so upon encryption, okay, now we're getting to the fun part. Upon encryption, the KMS plugin should provide a UUID identifying the local CAC and the encrypted local CAC as part of the metadata field in the encrypt response. The API server would then store it in SCD next to the DEC. Upon decryption, the API server provides a UID of the local CAC and the encrypted local CAC in metadata and the observed key ID from the last encryption when calling decrypt. This is so complicated. It's so hard to say. It's a mouthful.
Do we need a UUID for the local CAC? I mean, when it's encrypted, it's already unique, nearly unique, guaranteed. The probability for collision is very low.
We need it if it's not cached, right? If it's in SCD, but it's not cached.
So that's what I added as a comment, right? Like, so
Okay.
The cache logic, what we're doing, at least what we did in the POC, was very similar to what caching logic that API server does today. The cache key is actually the encrypted DEC. So in case of KMS plugin, the cache key will be the encrypted local CAC. And when it does a lookup, it basically just gets the encrypted local CAC from metadata and sees if that entry exists. The value is the decrypted CAC.
Yeah, so that's easy. That's basically guaranteed to work, right? Because you're not going to have collisions among keys, and if you do, encryption has gone off the deep end, basically. So yeah, I don't think we need a UUID at all in this case. I think
Okay. Yeah, I got confused. I was like,
don't feel bad. This sounds approaches spaghetti levels of detail, right? It's like all over the place.
so that means we should change this, right? Because
here's
longer...
the thing I want to definitely change. I don't want to see any more of this crazy prefix spaghetti in the storage. So what I want to see here is a similar implementation to what we do for proto storage, unencrypted proto storage for regular objects, which is that the object is prefixed with K8S:00. Like it's like something like that. And that prefix is stripped, and then the object within it is called the runtime.unknown. And it like basically has the proto object within it. Basically, that's how Kubernetes does proto storage today. Basically, I want to see like E for encrypted, K8S:00. So basically exactly that thing, and then have a new proto format that stores encrypted data instead of.
Can you type it in?
Yeah, totally. I can totally do that. But yeah, but the idea is that I don't want to have crazy prefix with colons and stuff. We were going to store it in a nice structured way as protobuf. And one of those fields will be the encrypted blob that is just a set of bytes. But all the other stuff, including the metadata from the KMS plugin and the key IDs and all that crap, whatever, is going to be stored nicely and structured so you can see it. Because today it gets shoved into this crazy spaghetti prefix thing. And then we'll be able to add new fields very easily, right? If we decide to add a new field, we just add it to the proto and we make sure the API server handles it not existing or whatever.
One question. So basically, when you encrypt with AES GCM, you need the nonce. And what it's quite common is to put the nonce in front of the encrypted blob, because the nonce usually doesn't change. So theoretically, you could make it smaller or bigger, the nonce, and it would be a variable that you would need. Like we're currently doing it, I think with ACVS, where we see how long it is. but we don't need it for ASGCM because it's more or less a de facto standard to have a 12 or 16. I would need to look up, but the nonce more or less a standard that theoretically could be different, but not. But most programming languages, or at least Java and Swift, I think, don't even support changing the size. So, and I just put it in front. Should we? Is it okay, or should we have a dedicated protocol for this, where we have the encrypted blob and the nonce that was used?
I'm not 100% sure off the top of my head. I could see arguments in both directions. My initial gut reaction is, where possible, to use separate fields in structure. That's my just gut reaction, because that's kind of my desire out of using a structured proto format, is so that's very clear what it is that you're looking at, instead of like bytes shoved together in very particular ways. Because today we basically rely on the CryptoByte API, right? Where basically it's like length prefixed arrays, and God help you if you go off the end in some weird way. And I just want to get away from that. I want to use nice structure and make it like today, like writing tooling for this stuff would be atrocious, right? Because you would be very carefully picking bytes and trying to figure out where everything is. Whereas like, because there's no way a human can look at it and get a sense. I want to get away from that and be able to say like, there's the fields, like you can see them and they mean separate things and they have good names and all that kind of stuff. And I realize protobuf is not the best format for having good names for stuff, because you need the schema and the value together to get the full detail, but our schema will be documented, right? So it's not as bad. But yeah, this is, I think, one of the larger pieces of the API server change, is to basically have a completely different storage format. I don't think this is controversial, by the way. I don't think anyone's going to be like, oh yeah, we want to keep shoving prefixes and crap together.
No. Okay, please come back here and update this. All right, I'm going to Mo.
Yes, totally. Yep, that's fine.
This is not the right you.
You're gonna do @MOK at VMware.
I'm okay. Okay.
Yeah,
oh my God.
Like I'm okay, but not really, because Mo is not.
Okay, I'll do it later. I hate that Google just shows every one of my contacts. Thanks, Google.
Yep. So a quick question. How, so today, all the encryption at rest stuff shoves in the name of the encryption provider into the prefix. That's good and bad. It's good because you can always try to kind of find who wanted something. It's kind of ugly because then you're stuck with the name of the provider never changing. Maybe that's okay. But basically, I'm curious how folks think this should be represented. Should we continue on this path and statically encode the name into the proto as a way of saying that, like, basically, if you don't encode the name in the proto, when you encounter one of these new proto objects that's encrypted protobuf, you basically would have to try every v2 alpha plugin that's currently configured, which in reality is probably going to be one. But if you have more than one, it's going to basically have to be like, do you understand this proto? Yes or no? Do you understand this proto? Yes or no? And like basically make network requests, right, to all of them. So that's a bad failure mode. But it's also, to me, kind of yucky to basically say, hey, this arbitrary string that you picked in your encryption configuration, you're not allowed to change it because it gets stored as part of the data in etcd. And there's no way to retroactively realize that whatever name you used was bad or confusing or whatever. Maybe this is not a real problem, but I don't like the fact that we have this strict correlation. Like, I feel like we can do better.
Wouldn't we need it at some point anyway, like to identify at least which, like for example, KMS is used for the encryption of this particular data? Like at some point we discussed that we wanted to add some maybe CLI tools to be able to introspect the data that is stored in etcd and maybe decrypt it manually if needed. So at least we will need a way to identify which target should we put to like decrypt whatever data we want.
Yeah, I mean, I guess maybe one thought around this could be is, does this configuration belong within the encryption configuration that's static for the API server? Or is this actually, should this actually be part of the status response from the KMS plugin itself? Like, does the KMS plugin get to decide its name? Again, it still has the same problem of like, once you decide your name, you can't change your name. Right, because it's
Yeah, if you change your name, it triggers a storage version migration.
well, no, if you change your name, the Cube API server will no longer try to contact you for decryption because it won't think you know.
From the encryption config.
Yeah, that's the thing, right? If you build this strong one-to-one mapping, the API server is going to enforce that mapping. And it's good for like performance, but it's bad for flexibility.
Or migration down the road.
Yeah, I mean, but you could argue that maybe this migration shouldn't occur. Maybe you should just pick a good name and just be okay with never changing it. I don't know. Like, I don't like telling people that don't screw this up because there's no take backsies. Or the take backsies is really hard, which is basically configure the new plugin that's the same plugin with a different name and do storage migration from one to the other. But this is the hard storage migration where you do have to do like the full orchestration of your plugins and everything. It's a lot of work to change this name, basically. But maybe this is not a real problem.
Actually, how does that changing this? How does that impact the backward compatibility problem?
So it doesn't at all, because at least my proposal on this is we do not touch any of the existing stuff, like at all. And also we basically can't, because if we're futzing around with alpha APIs, we're not allowed to go like change the behavior of existing.
Right.
So if we want to maybe at some future point normalize all the providers to use this much better format, that's totally fine. Let's please leave that out of this, because this KEP is already like massive, and I don't want to argue with people about fixing old mistakes right now.
Okay. We have like 4 minutes left.
Yes, I do have a hard stop.
So the rest, honestly, the rest aren't as, I think the rest are pretty much just an extension of what we already discussed. This is why I want to talk about the high level first, because I feel like if we mostly agree with the high level, the detail stuff shouldn't be that bad, honestly. So please review the rest of the doc. And then for the highlighted stuff, Mo come back to update this, and then, naming things like what's the feature flag? I don't know. But we need to come up with a name.
So my straw dog would be just call it this. Call the KMS v2 with a space, and call all the featured gates just KMS v2 with no space.
So I did look up other feature gates. There's no version in any of the feature gates. I think that's might be kind of weird to have version next to the feature. I don't know, just a thought.
Yeah, I mean, it took a long time for us to like get to pod security admission from PSP. Like, it's really PSP v2, but like this, I don't know if this has a good name, right? Because we're not really changing the final result of the API, which is encryption at rest, right? Pod security policy to pod security admission is actually like incredibly different, because the policy is different. It's static, it's versioned, it's based on labels. Like it's like a different world approach to like policy enforcement on pods. This is basically saying we still want the same encryption at rest at the end. We just want you to be able to run it in production without like blowing up your environment. And we don't want to try to fix the API in place. We just want to use it. Like, we just want to make a new API, get it right, and ask people to migrate to it. Also, how do you all feel about a goal of deprecating the V1 beta API 3 releases after this GAs? I'm curious if y'all think that would be controversial. Like,
depends on adoption, right?
No, that's what I'm saying is like the idea would be if you have a V2 API that is GA, you're allowed to deprecate the old.
So like pod security, yeah, gotcha.
Right. So, but we could also like we don't have to remove the old one, but I kind of feel like we should. Like I feel like we should give lots of time. Like I'm okay even at 6 releases or 9 releases, right? Like multiple years if people really want that. But I want to actually say that we don't have perma beta APIs. Beta APIs do go away. And this beta API did not graduate. Here is their replacement. It does every single thing that the old one did, but better. Please migrate.
Okay, let's just, I mean, we're not gonna get the answer today, so.
Yeah, no, it's more of just to think about it, right?
Yeah,
like,
yeah, for
we all have
sure.
opinions in either way.
sure.
I think the challenge actually will be that this particular feature depends on plugins that are written by the community. And if we tell them that, well, their plugin won't be usable anymore in 3 release, they need to adjust. Like we cannot expect everyone to really re-implement their all plugins right away.
Right. No,
So
that's what I'm saying. Like, but there has to be a cost for building a production environment on a beta API.
Yeah.
Right? And this is the cost. This is what happens when you do that.
Okay, great discussion. Thank you for all the feedback. Please go and comment more. But I would like to set a date for pushing the PR through just to get people to start reviewing outside of this group. So can I ask that everybody get their, like, should we say let's push the PR by end of the week? Does that sound good to you? Yeah, okay.
I would say that if we don't get it out by end of this week, we're going to have a very hard time getting reviews. Like for example,
Yeah.
Gordon already said that he's going on vacation.
I know.
That's
why do you think I'm pushing? Why do you think I'm pushing, Mo?
Yeah, so
I know he's
will
going
not
on
be
vacation.
around for last.
I know this. Anyway,
yeah, we basically have to, right? If we don't, we just won't be able to get it in.
yeah, I know.
There's a lot of detail. The only thing that makes me hopeful is we're asking for just alpha, right? So if we don't get complete agreement, it's okay if people feel confident enough to approve an alpha, so we can start the work, right? Because some learning actually happens by writing code, right? You can't always just know everything. At least I can't.
No.
I think I would be like, honestly, I'd be very surprised if we can beta in 126. I'd be very surprised at that. Because there's just a lot of stuff to do here.
Okay. Again, please help review this. That way, hopefully it will reduce the time other folks have to, like, push back on the PR, right?
Yep.
All right, so I will ping you that before end of Thursday to just another reminder, and hopefully Friday we can get the PR out. All right. Thank you, everybody, and happy birthday again.
Thank you.
All right.
Thank you a lot. Bye.
Thank you.